When we talk about AI in medicine, we're almost always chasing one thing: perfection, right? We want an AI that is totally flawless, completely unbiased, and 100% right every single time. But what if that's the wrong goal entirely? Let's dive into this really fascinating new paper that suggests we should actually be embracing AI's flaws, not trying to erase them.
I know. It's a provocative question. For years, the story has been that bias is the big, bad villain of AI. It's this critical defect that we have to hunt down and stamp out, no matter what. But let's just pause and challenge that for a second. And look, let's be absolutely clear. The stakes couldn't be higher. In the medical world, a biased algorithm isn't just some tech glitch. It can lead to real, devastating consequences. We're talking about wrong diagnoses, making health inequities even worse for whole communities. The harm is very, very real.
So naturally, regulators are all over this. The FDA, for instance, has given the green light to over 1,000 AI tools, but they're hitting the brakes on the big, large language models. Why? Mainly because of these bias concerns. And over in Europe, the EU's AI Act straight up labels medical AI as high risk. This puts huge pressure on developers to prove they've basically eliminated bias. The whole system is pushing for this one single perfect AI, a goal that might actually be impossible.
But what if we've been looking at this all wrong? A new paper is proposing a really radical shift in thinking. It's asking us to stop seeing AI's imperfections as a bug, and maybe, just maybe, start seeing them as a feature.
The paper, from Farhad Abtahi and his colleagues, lays out this brand new framework. And their core idea is this: instead of trying to force a bunch of different AIs to all agree on one single correct answer, what if we orchestrated them in a way that preserves all their different, diverse, and yes, even biased outputs?
And here is the absolute key to the whole thing. What if an AI's bias isn't just a mistake? What if it's actually a sign of specialization? Think about it. An AI trained in one specific part of the world might be biased, sure, but it could also be an incredible expert at spotting a rare, local disease that some giant, unbiased global model would totally miss.
So that brings us to their solution, which is called MEDLEY. Honestly, the best way to picture it is like an AI by committee, or think of it like a digital tumor board. The goal isn't to get everyone to agree, it's to have a really rich, diverse consultation.
So formally, MEDLEY stands for Medical Ensemble Diagnostic System with Leveraged Diversity. It's a system that brings a whole panel of different AIs to the table, and instead of just averaging out what they all say to get one answer, it presents all of their viewpoints, especially the disagreements, to the human doctor.
This chart really nails the difference. On the left, you've got the traditional way of doing things. The goal is always to maximize accuracy by squashing all the outputs into one answer. Any disagreement between models, that's just noise you need to get rid of. And bias, that's a defect you have to eliminate. But MEDLEY flips that entire script. The goal is to provide a bunch of different perspectives. Disagreement isn't noise, it's a valuable signal that there's some uncertainty here. And bias isn't a defect, it's a form of expertise that you document and actually use.
And this is how it actually works in practice. It's a three-stage process. First, you've got parallel inference, where you take a clinical case and run it through a bunch of different AI models at the same time. Then, stage 2, the orchestration engine takes all those outputs and analyzes them. But it's not looking for a single answer. It's mapping out where they agree, and crucially, where they disagree. And finally, stage 3, it presents all of this to the clinician as structured insight. You get the consensus view, you get alternative ideas, and you even see the outlier opinions, all with their known biases clearly labeled.
So you can see this isn't just some clever idea for a research paper. Thinking this way has massive real-world consequences, especially for how we regulate AI and for the entire community of innovators building these tools. Okay, think about getting approval from the FDA or complying with the EU AI Act. The current path is a nightmare. Developers have this almost impossible task of proving a negative, that their single model has zero harmful bias. The MEDLEY pathway changes the game completely. Your new goal isn't proving perfection, it's proving that your system makes bias transparent and clinically useful. So you shift from validating one model to certifying a smart, transparent committee of models.
And here's where it gets really exciting for the industry. This idea completely challenges the whole race to build one giant, all-powerful supermodel, a race, by the way, that only a handful of big tech companies can even afford to run.
By valuing all these different AI voices, MEDLEY basically creates a new ecosystem. All of a sudden, a small startup that builds a brilliant model just for one rare disease doesn't have to compete with a tech giant.
they can become a super valuable member of the AI committee. This lowers the barrier for everyone to get involved. It's kind of like creating an app store for medical AI, where tons of different innovators can contribute their piece of the puzzle, and that could really speed up medical breakthroughs for all of us.
And ultimately, what this all does is it totally reshapes the relationship between doctors and AI in the clinic.
The clinician isn't just a passive user anymore, clicking accept or reject on what a single AI tells them. No, they become the conductor of an AI orchestra. Their human expertise is what allows them to interpret all these different digital voices, understand the nuances, and synthesize that whole symphony of data into the right final call. The paper makes this perfect analogy to Garry Kasparov's advanced chess. After he lost to a supercomputer, he discovered something amazing. A good human chess player paired with a team of computers could consistently beat both the best human grandmasters and the most powerful supercomputers, acting alone. The goal here is the same. It's human-AI symbiosis, not replacement.
So it really leaves us with this final thought. When it comes down to our health, what's actually the safer, smarter bet? Chasing this impossible dream of a single, perfect AI, or putting our trust in a collaborative team of specialized, imperfect AIs, all guided by the wisdom and intuition of a human expert? The answer to that could literally change the future of medicine.